Okay, well, I'm good. So, okay, hi. My name is Rosie Sokolov, and obviously this is my SYP. So, when I was thinking long time ago about like September, what I wanted to do for SYP, I knew that I wanted to do something that had a combination of three things. One, I knew it wanted to have some aspect of like experimentation or creation, so I would end up with an actual product, which you can see right there. And two, I knew that I wanted it to have an aspect of academic learning, so I wanted to do some in-depth research on something. And three, I wanted it to be something that I didn't know anything about. So when I started thinking of topics that fit these three categories, one of the things that I came up with was a sense of smell. And so I started thinking about perfumery, because I realized I have no idea how perfumes are made and how they used to be made and what the history of that is. And it also has this really interesting academic background in psychology and neurology. So I realized that I could kind of explore those two different fields. So when I started thinking about the history of perfumery, I learned that it actually came from early alchemists who were really interested in, obviously, making gold out of base metals. So they were really interested in kind of finding this essential, kind of spiritually weird thing inside these metals. And so a lot of alchemists actually branched off and thought, hey, I bet there's something like that in plants, because they also had this kind of spiritual connotation there of the earth. They have these fantastic colors and smells, so they started trying to extract those essential oils. And then after that came early perfumery, and this is when the basic setup of a perfume was made. So the way that that works is there's like 3 base notes, 3 middle notes, and 3 top notes, or 4 actually. So there's 12 different sets of notes or odors in a perfume, and then there's a 13th. It's kind of like the extra pizzazzy note. So that's when this was set up. And then around 1900, synthetic odors were starting to be developed. So basically this was like Chanel No. 5 was the big first synthetic perfume that was made, and it really popularized this kind of synthetic approach, because people used to think that only natural odors could have this kind of great smell, but Chanel No. 5 was kind of like, oh yeah, it embraced this kind of harsh smell, so people thought that was really great. So I realized that this really led really well into a project and a paper, and my project was to distill natural scents found in my garden and around my house, and my paper was to, which came a little later, was to see if I could figure out if certain odorants were more capable of evoking memories than other categories. So I realized this was my SYP. So I divided it into 2 sections, and so my project I'll talk a little bit about now. This is actually linked to my wiki, which doesn't work in the Prezi, but I'll just talk about it. So this is the first instrument that I started with. It's called a still, and basically the way it works is that you fill this with water, and you put some packed dried plant material in this little vial right here, and you start boiling the water. Steam comes up through here, it goes into this, which is called a Kjeldahl ball, and basically the function of this part is that if the water starts boiling over, it'll come into here, cool down because there's more air, and it won't actually like flood your plants. So that's basically like a safety mechanism. So the steam will come down here, it goes through the packed plant material, picks up the odorants, and goes through this middle tube in here. And I know it's a little hard to see from there, but there's an inner and an outer tube. So the inner tube is the one that comes out this end here, and that's where the steam goes through and eventually falls out into your whatever you're having to catch it. And the tube on the outside is where you put your coolant, which is water. So, you put the water through the funnel, it falls on the outside of the tube, takes away some of the heat of the gas, so the gas recondenses, forms basically a water, because that's what it was there, except now it has smell, and falls out the end. And obviously this collects the coolant. So that was the basic setup, how I started. It broke eventually, but that was okay because I have another setup at home, which I couldn't bring in because it's too cumbersome, but that's basically the same idea, except it uses milk jugs and copper wire and like a tea kettle. So it was really interesting, and I actually realized that in order to do this, it involves a lot of experimentation, because I realized that you can't just boil the water because that gives it this kind of harsh, weedy smell. and also that it takes different amounts of time, and you have to do different amounts of material. So these are my smells up here, and I guess if you can get up and smell some of them, that'd be great. I have little name cards for each of them, so if you can try to guess what they are. Some of them you won't be able to because they're kind of weird, but the way I've arranged them is that on my left, your right, that's the first smell that I made. And that one is pretty easy to tell what it is, I think. And then, so the two next to that, that's an example of a synthetic odorant, basil, versus the natural one that I made. And they kind of smell a little bit similar, but you can tell, I think if you smell, that the basil, the synthetic one, is a little bit harsher. Then next to those three, yeah, I know, it's kind of complicated. But next to those, I have three that I made out of white flowers that were in bushes that I found around my house. And next to that, I have two that I distilled in alcohol, which is another way of distilling it. So yeah, some of them smell pretty funky, but I'll get to that in a sec. So then I have two, one is in the old anise bottle, and those I distilled in alcohol. And in order to do that, you basically like put in your plant material, sieve it out, and put it in, and it takes like a few weeks, and you have to shake it every now and then. That's fine. That one is soaking in olive oil, which is funny because it has a bit of its own smell. Those are a little hard to open if you just, pull out. Yeah, that one's a little funky. And then on the end, I have three herbs, or, well, one of them is a chive. But anyway, yeah, that's rosemary. It smells weird. Anyway, so basically in order to do this, I planted a lot of things in the greenhouse at North earlier this year, and I grew them. I planted them in my garden, harvested them, dried them, which took a few weeks, and distilled them. And so I came up with this array of scents. And when I was thinking about doing this, I realized that the ones that worked really, really well were the Christmas tree, the herbs, and the chives worked pretty well, and they smell like what they're actually supposed to smell like, as is the pepper, which is weird because you don't think about pepper having a smell. But then the ones that smell really funky are those three that I made out of the white flowers. So that got me thinking about why that didn't work. And I tried experimenting with them, tried to simmer the water, and took longer. But basically, what I think happened is that those molecules that have the smell are much more volatile than the other ones are. So when you expose them to stress like heat and pressure, they break down and they don't smell the same. And so I started thinking about why those certain molecules are like that, and this led me to my question, which is, different odorants apparently hold up under stress better than others do, and does this have any effect on how they relate to memory? So first, in order to figure this out, I had to think a little bit about and research what olfactory memory is like. How does it work? So it starts with an odorant, which is basically any molecule that has a smell. And after that, it goes to these things called cilia, which are basically little like hairs at the top of your nasal cavity that are protected by mucus. And here is where the molecules, they bind to the cilia, and there's two theories that people debate about how this actually gets a message into the neuron. And the first theory is the shape theory, which is at base basically like, oh, mustard smells harsh, so it's a pointy molecule, or rose smells nice, so it's a smooth molecule. And there's different variations on this, and it gets kind of complicated, and it's more scientific than it sounds, but there's this guy, Luca Turin, who's recently refurbished the vibrational theory, which he thinks is really more scientific and sound. And basically the vibrational theory explains that the message isn't based on the shape of the molecule, it's based on the specific vibrational energy that it has, because electrons are moving all the time, spinning and vibrating. Every molecule has a specific energy, which is measured in hertz. So basically he found this one molecule, borane, it smells like rotten eggs, mostly because it has this like little group that's called a thiol that basically smells like rotten eggs. And so then he started to try to find another molecule that might smell like it, and he found another one, and he studied it, and he found out that not only are their smells very similar, but their vibrational energies are really similar. So he's, expanding on this theory and trying to prove it. And after the cilia, the message goes up through the olfactory nerve. And the way that this works is by a thing called an action potential, which is essentially like an electrical impulse that involves chemicals and depolarization. So it's kind of complicated, and I won't get into it now. But the olfactory nerve is basically, there are a bunch of neurons that lead back into your brain. And what's really unique about the way that smell works is that the way most others, like touch and sight and taste work, is that they go through this part of your brain called the thalamus, which is basically like on the top of your spine, which is like the big control center. And so they go through there, and then they're processed, and then they go out to other parts of your brain. But the way that smell works is that the olfactory nerve goes straight back to the olfactory cortex, which is like kind of in the front part of your brain, and which is also surrounded by this thing called the limbic system, which is this really, really old part of the brain that deals with like memory and emotion. So it seems like maybe this kind of like visceral reaction that you can get, or memories that come back when you smell something, might be because it doesn't go through the thalamus, so it kind of avoids this certain processing, and also it's really closely connected to parts that deal with memory and emotion. So it goes to the olfactory cortex, and basically it passes over this thing called the olfactory bulb, which is where they think it, like, different categories are divided. So it's like, oh, all the stuff that talks about whether it's pleasant goes to this section. All the stuff that talks about whether it's intense goes to this section. Then it goes back up to the olfactory cortex, which is divided into left and right hemispheres. And the left hemisphere deals mostly with emotion, the right mostly with memory, the right mostly with emotion. The left deals mostly with whether it's pleasant, the right deals mostly with whether it's intense or not. So then this all creates this thing called, as Antonio Damasio, a psychologist, said, the movie in the brain effect, which is essentially like how all these different somatosensory informations bring us to this kind of cohesive consciousness that we feel as humans. So this led me back to my question of how these odorants have a different effect on our memory. And so I thought of 3 main reasons why this might be the case. And the first, I think, is an evolutionary reason. And because scientists think that olfaction probably developed in order to help organisms tell whether food was rotten or good to eat. So if something smells rotten, it smells bad, you don't eat it. Something smells good, you're good to go. But so basically, organisms with a good memory survive, organisms without one eat rotten food, die. So basically, it seems that it makes some amount of sense that it would be easier to remember the molecules that smell bad, the ones that you have to avoid, rather than the ones that are like, okay, good to go, because the ones that smell bad have more important information to them. So possibly these averse smelling molecules are easier to remember. And the second one was the volatility of odorants, which is kind of my field work. So I was thinking about, what odors you're likely to encounter, and it's been pretty much proven, although you're not supposed to use that word in science, that the more you encounter a smell, the more memories you'll have tied to it. So if there are these molecules that break down really easily under stress, like heat, pressure, then it would be, you wouldn't encounter them as often. Like white flowers, you don't encounter that smell quite as often as you might like a fir tree, also just because it's bigger. But also, if these molecules are more prone to break down, then smelling them is likely to be harder and might not be able to send as strong of a message back to the olfactory cortex. And the third was a difference in shape or vibrational energy. So if there's a molecule that has a super distinct shape and needs to bind to like a really specific kind of binding site, it seems that maybe that would have some sort of more concrete connection than one that could bind to maybe 5 different binding sites. And the same with vibrational energy too. So the importance of all this talking about smell and memory is that it actually has a really big impact on things like therapy and also studies on obesity, because there have been studies where like experimental groups of sleepers have been subjected to the smell of a rose while they're sleeping, and they tend to have better dreams. So this could have kind of implications in sleep therapy, maybe therapy in general. And also one of the big things about obesity that people haven't thought about a lot is that, yes, it really depends on, the taste of the food, but taste is so closely connected to smell. They're the two chemical senses. That smell also has a huge part to do with it. So further research on that aspect of the obesity problem might have some impact there. But really, I think that the biggest implication that research on olfactory memory has is that it'll help elucidate how memory works in general, because that's something that psychologists and scientists really don't understand. They know kind of where it works, they know kind of how it happens, but they don't know how memory is stored, and they also don't know how it creates the kind of movie in the brain thing. And since smell is so strongly related to that, research on it will really help elucidate that. So, thank you. Is it question time? Yeah.
I'm going to try to find the question as I'm doing.
Okay.
I'd love to hear kind of more about the whole vibrational energy versus shape
Mm-hmm.
Debate there. Is this how old is this vibrational energy? Like, it sounds like he's still working on it. Like, when did this kind of come up? And I'm still trying to figure out the difference between the shape and the shape versus vibrational energy.
Okay. Well, okay, so shape theory is basically something that's used in like all of biology. So, there are these things called neurotransmitters that basically send messages all over your body, and they bind to specific sites based on their shape. And the binding sites have to have a specific shape so that they can fit. It's called the lock and key mechanism. And basically what Luca Turin thinks is the issue with this is that there's so many different molecules that you can smell that in order to be able to smell such like a vast array of them and to be able to identify all of them, you would have to have this huge, huge mechanism in your nose, which is called a centrospector. And when they have them in labs, they're these like massive, massive things. But there's also another type of equipment you can have that tells the vibrational energy of a molecule that's like much smaller, and people have made them microscopic. So he thinks that basically, in order to be able to smell so many different molecules, you'd have to have like a million bajillion different binding sites, and it would be too complicated, and they wouldn't actually be able to like fit, essentially. And the vibrational theory, he thinks, makes more sense because they could bind to some of the same binding sites but just send different messages. And that theory was brought up in like, I'm gonna say 1922, by this German scientist who actually found the same pair of molecules that Turin found. And he wrote this really, really long paper about it, but then nobody ever really followed up on it until Turin came along, like probably like 1990s. He was like a perfumist by trade, and then he thought, hey, wouldn't it be so much easier if we could figure out like different synthetic things by finding their vibrational frequencies rather than just kind of like casting a wide, wide net and like looking for anything. So he thought of that first, and then he went back and he checked it, and he was like, oh yeah, there is a history here. Yeah. Yeah.
Hi, Rosie. I wanted you to talk a little more about the 12 notes in a perfume you said, and then the one that you said pizzazzy odor. I really, this is definitely a topic that I never think about until I think about, like how is perfume made. So I think you were saying that in reference to how a typical composition of perfume, like the 12 notes.
Yeah. So basically the way like modern perfume works is when you put it on, you smell something initially, which is usually this like really alcohol-y scent. I don't know if you smelled the synthetic basil, but it smells really strongly like alcohol. And so basically and what you're smelling first, those are the top notes. So those are the notes that stay for maybe like a second or maybe a few minutes. And so then those, because they're kind of volatile, they evaporate quickly. And then you can smell the middle notes, which are a little more stable. And so those you smell next. So like a few hours into wearing a perfume, it actually smells different than it did when you put it on, which is something that a lot of people don't realize. And then like many, many hours after that, those notes have evaporated, and the next ones are the base notes, which are usually something like musk or civet, which are basically made out of the fat of animals. And those are supposed to be like the most erotic or like base scents. So those are usually the ones that are kind of the biggest base notes. They're really used a lot. But like the flowery floral things, those are usually like top notes that you smell when you like open a perfume in the store and you're like, that smells like violets.
What kind of research did you do? Did you use books, the internet mostly? Did you use any sort of like textbooks? Can you talk a little
Yeah.
bit about your research process?
Well, so a lot of this I knew, or I vaguely remembered from taking AP Bio last year, and I also took Psych this year. So a lot of the like basic information I knew. And then for the history of perfumes and stuff, I read a lot of books from the library, but mainly, I talk about this a lot more in my paper. It gets a lot more technical and in-depth about the researchy stuff, but I read a lot of labs that people did about like, do women or men have better episodic memory related to pleasant odors in an outdoor setting? So I read a lot of labs like that, which kind of helped inform my thinking about how to do labs related to scent and also how to answer my question. Mm-hmm. Yeah.
I have a kind of random question. In your research, do you find any information about, like I know with my perfume, I can't even smell it anymore because I'm used to it. You know, if I were to wear a
Mhm.
different one, then I would, I don't know, just how your brain just kind of shuts off
Yeah.
your own, a certain smell if you're accustomed to it.
Well, one of the things that's also really interesting about smell versus other memories is that they don't really understand whether there is like a long-term, short-term, and working memory, which is basically the way most other things work. So like working memory is whatever you're processing right now. Short-term is something you remember for like 9 seconds, and long-term is, you know, long-term memory. So the way that they think that it works for smell is that it doesn't, there's probably some sort of a working memory, but it's not something that you like are super consciously aware of the way you are when you're seeing things. They don't think that there's any sort of like short-term memory. So like, you know, when you look at something and then you look away and you have that like after image, they don't think that there's that kind of thing for smell. But they do think that there's a long-term component, and I think that the kind of habituation of the perfume is probably like habituation in most other senses, where you're exposed to a stimuli really often and eventually it kind of, its effect on you wears off. Yeah.
What's next? Having done all this research and found out all this information about perfumes and smells and memory, what's next for you? Does this research and project just end, or is this going to help you carry through?
Well, I think, so I'm going to college next year, and one thing this project really helped develop my love of learning about psychology and that sort of sciencey stuff. The perfumes, I really see as more of a means to an end than an end in themselves, because what I really took out of this project was not just learning about memory and making these things, but it was really more about working on a project in general. So I found out that what I really need to be able to do with long-term projects like this is I need to have something where the product will be something that I can kind of work on and keep working on, like, you know, experimenting with them and trying different types. And also it has to be something where I'm convinced of a greater importance of my project, because I really do think that there are some implications of what I've done, but I also find myself a little bit like thinking about, like, what if I had taken this in another direction where I could have thought of kind of like greater implications. So I think it's helped me think a lot about my own education as well. Thank you.